Okay, let's have a look at this last bit. This is perpendicular lines. That's a symbol for perpendicular. Perpendicular lines. And when we find a line that's perpendicular to another line, we can do it very simply. So if I, for example, had an equation that was y is equal to 2x plus, or 2x minus 1, let's do that one, and I want something perpendicular to that. Well, let's draw it for a start. Here it is. It's my y, my x. Starts at minus 1. There's my minus 1. And it goes, the gradient is 2, so it's going to be 1 long, 2 up. 1 long, 2 up. 1 long, 2 up, and so on. And so the line is going to look something like, if I can draw it best as best I can, something like that. Okay, arrows both ends, arrows everywhere else. Yeah, arrows everywhere. And there's my line of y equals 2x minus 1. Well, a line that's perpendicular to that will simply cross at 90 degrees. So if we know a particular point on this line, and let's say we wanted to find the line that passed through, and this point here is going to be, looks like 1, 1. Yeah, that point there's 1, 1. So if we wanted to find the line that was perpendicular to that passed through that point, this would be at 90 degrees. We'd have a 90 degree angle to this. Well, how do we know what that is? Well, we've got a point here, and so the point we've got is 1, 1. And I'm eyeballing this one. I can see it's 1, 1 because we've just gone 1 long and 2 up. So that must be 0, that must be 1. And we've gone 1 out, and 1 up. So this must be 1, 1. So that we just know that. But we also know the gradient of this, m, is in this case 2. So if we want to find a perpendicular line, all we do is we make that negative and find its reciprocal. Here is its reciprocal, and here it is being negative. Yeah? So we're going to find the negative reciprocal. So we're finding the negative, we're going to find the negative reciprocal. Okay, so let's have a quick look at some negative reciprocals. Here we are. So if I've got a 2, a negative 3, a half, 4 over 5, negative 6 over 7, 3 over 2. Which one have I done here? Make that a negative. Let's go negative 1 half, negative 6. Here we go. Let's go ahead and find some negative reciprocals. So it's just 1 over what it was before. Well, 2, we know what a negative reciprocal of 2 is, because it's going to be, there's my 2, it's just 1 over, and it's negative. So that's the negative reciprocal of that. What about the negative reciprocal of negative 3? Here's my negative 3. Here's my reciprocal. And if we make it negative, a negative makes it positive. Here's my half. Now, if we find the reciprocal of a half, really when we have a fraction, all we do is we flip it up the other way. So that goes there, and that goes there, and we make it negative. So it's going to be 2 over 1, which is just 2, and we make it negative. 4 over 5, we're going to flip this up the other way, and we're going to make it negative. So it's going to be 5 over 4, we're going to make it negative. Here we are, 6 over 7, it's going to be 7 over 6. We're going to flip it up the other way, and we're going to make it negative. It's negative now, so if it's already negative, and we make it negative again, we make it positive. Here we go, 3 over 2. So I'm going to flip it up the other way. You're flipping it the other way, makes it 2 over 3. It was negative, but now, of course, a negative makes it positive. Negative a half, so it's flipping up the other way, so it's going to be 2 over 1. Well, of course, 2 over 1 is 2. It was negative, and now it's positive, so let's put 2 here. A 6, well, of course, a negative 6, in fact, not equals, negative 6 becomes negative 1 over 6. And of course, it was negative, so we make it negative and make it positive. So that's all we're doing. Now, the proof of all this is we know any reciprocal, if we take the two gradients and we multiply m1 times m2, they must equal negative 1. So we're going to find the gradient. We've got a gradient of this one here is 2. We're saying the gradient of this one must be negative a half. If one is at right angles to the other, then the 2 times the negative a half, the 2, that gradient there, times this gradient here, that's reciprocal, negative reciprocal, must equal negative 1. Let's check that. So here's the original one, it's 2 times negative 1 over 2. Does that equal negative 1? Well, 2 times negative 1 is negative 2 over 2. Negative 2 over 2 is negative 1. Yes, therefore, you can say negative 1/2 is it's a perpendicular gradient to 2. And that's what we say. Let's find this though. So we're saying this gradient here goes through point 1, 1. It's perpendicular reciprocal. It's blah, 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 blah. Okay, let's see if that's true. Let's see if it passes through that point, and let's see what it would look like. So here we go. We're going to go y is equal to mx plus c. I'm going to write the points down. I got 1, 1. I've got m is equal to negative 1/2. So let's have a look. This is my x value. This is my y value. Y is 1. X is 1 times negative 1/2 plus c. Well, 1 times negative 1/2, so it's 1 is equal to negative 1/2 plus c. I'm going to add 1/2 to both sides, add 1/2 to both sides. So c is equal to 1.5 or 3 over 2. I was going to 1.5. So where does this lead us? Let's take a look. So over here, this is going to be 1 is 1. Let's call this 2. This 1.5 is going to be there. This is 1.5. There's that line. 1.5, that point there. And so it's going to go on an angle through there and through there. Here it is. It's going to go down like this. It's going to go through 1.5. It's going to go through there. And notice the gradient now. It's going, in this case, 2 along, 1 down. 2 along, 1 down. Here it is. 2 along, 1, 2, 1 down. 2 along, 1 down. Yeah? Here we are. So it does work. It is true. So that is finding a gradient. It's finding a negative reciprocal. All right, let's do one that it wants us to do. Here we go. So I'm just going to go straight to their questions. And they've got gradient of. They've got, where are we? Oh, it has a gradient of negative 1/2. We're going to find the equation. Oh, no, wait, that's the wrong one. Parallel cuts, passes through perpendicular. Here we are. Which a line is perpendicular with a gradient of 1/2 and cuts the x-axis at negative 1. So here's my graph. Cuts at negative 1. There's my negative 1. Cuts at 1/2. Sorry, gradient is 1/2. So m is equal to 1/2. The x value here is negative 1. Oh, sorry, my bad. Cuts the x-axis at negative 1. So x-axis at negative 1 is going to be here. Okay, so this is not here at all. Okay, not doing well. All right, so cuts there. There it is. And it's got a gradient of 1/2. So it's going to be, in this case, 2 along, 1 up. So let's do that now. 1, 2 along, and then 1 up. 2 along, 1, 2, and 1 up. So this is what the graph looks like at the moment. There it is. And we are going to do that. What are we going to do here? What is perpendicular, it says, to a line with gradient of 1/2 and cuts the x-axis at negative 1. Well, we're going to cut at the same point, so we'll cut over here. Yes, it's going to cut there. So here's my y. I'm assuming actually that's what it's asking me to do. We're going to cut that's going to come along and cut at this point here. And it looks like it's going to be, because we want this, when it cuts here, when it does this, we want this angle here to be a right angle, yeah, because it's perpendicular. So the new graph must have an m value. So the m value must be the negative reciprocal. So 1/2, we're going to flip it up the other way, so it's 2 over 1, and make it negative. So in other words, m is equal to negative 2. So now we've got an m value of negative 2, and it's going to cut the graph at this point. So I'm actually going to use, we actually have here the point of that, don't we? Because it's not just cutting the x-axis there, that's actually a point, and the point is negative 1, comma, 0. It's going negative 1, comma 0. There is my x and there is my y. So let's go ahead and put that in. So we've got y is equal to mx plus c. So let's have a look at that. So the gradient, gradient is going to be negative 2. So I put my negative 2 in there. I've got an x value of negative 1 and a y value of 0. X value of negative 1 and a y value of 0. So 0 is equal to negative 2 times negative 1 plus c. So this is negative 2 times negative 1 is going to be 2 plus c. If I subtract 2 from both sides, c is equal to negative 2. So therefore, y must equal, what is it going to be? Oh, negative 2x minus 2. And that is my equation. Let's see if that works out. So it must cut at negative 2. Oh, look, we said that was about a 1. That's about a negative 1. That looks like about a negative 2. So it looks like it's going to head down here like this and head up like this. And there is my new line. This is my y is equal to negative 2x minus 2 line. All right, hopefully that makes sense. So that was for perpendicular, perpendicular lines.